Good evening, everyone. I, Anjali Sharma, along with my co host Prateek Mane, am honored to welcome you to today's webinar on Renewables Redefined Unlocking Geothermal Energy. As we accelerate the journey towards net zero emissions, exploring all the avenues of clear energy is imperative. While solar and wind power dominate the discussion, geothermal energy remains an untapped powerhouse capable of providing reliable, baseload renewable energy.
To help us unlock the true potential of geothermal energy, we are privileged to welcome our esteemed industry leader, Mr. Andy Wood, the Chief Executive Officer at Renewable Energy.
It's our honor to welcome Mr. Andy Wood, Chief Executive Officer at Renewables Energy and a passionate advocate for geothermal energy with over 30 years of experience in upstream oil and gas. He has played a key role in operational optimization, cost reduction, and efficient improvements across 25 countries, including UK, Norway, East Africa, and Azerbaijan. In 2020, driven by his commitment to sustainability, he transitioned to geothermal energy, applying his extensive expertise to accelerate its global adoption. As a founding member of the Geothermal Energy Advancement Association, a mentor, and a guest lecturer, he is dedicated to raising awareness about geothermal's vast potential in energy transition.
Currently leading Renewable Energy, Mr. Wood is driving efforts to make geothermal a mainstream renewable resource. His expertise bridges the gap between oil and gas and clean energy, helping shape a more efficient and sustainable future. Today, he'll share insights on unlocking geothermal energy potential. Mr. Wood, the stage is yours.
Thank you very much. I will just share my screen and then begin my presentation. Um, I appreciate the introduction. Thank you very much.
Thank you.
And just let me know when you can see the presentation. I guess it should be there now.
Yes, sir.
Great. Thank you very much. Um, all right. As I say, thank you very much for the introduction. I'm going to talk to you today about the future of geothermal energy and specifically about how the oil and gas business crosses over into geothermal and is helping with the proliferation of geothermal energy. It's a recurring theme throughout the presentation. So an SPE audience is probably going to benefit a little bit from what I'm saying. And I encourage everybody to look into the benefits. And hopefully by the end of this slideshow, you'll understand a little bit more about what geothermal energy has to offer. So I'll begin by talking a little bit about modern geothermal energy and the performance to date. The first electricity from geothermal was generated in 1904 in Tuscany. Today, geothermal energy only produces 0.4% of the global electricity supply, which is very disappointing for somebody coming from the geothermal energy business. However, at the end of 2024, the International Energy Agency published a paper called The Future of Geothermal Energy, the same as my slideshow, coincidentally, and they predicted that geothermal energy would produce 15% of the world's electricity by 2050. And this does not include direct heating and cooling. So the prediction by the International Energy Agency is a significant vote of confidence for the geothermal business. And their prediction comes from the way that the geothermal industry has developed over the last 5 to 10 years. The reason that geothermal has been a relatively poor performer for the last 100 years is that there have been confusions about technologies that are available, and also related to awareness of what geothermal energy could potentially do. And then you also add to that incentives of the past. But there are plenty of lessons that we can learn from the past, both regarding perception and actual project failure. So the first thing that's worth pointing out is that geothermal energy has a reputation for only working when you live next to a volcano, essentially. When you speak of geothermal energy, most people think of Iceland. Even though Iceland is only the 9th largest producer in the world of geothermal, it's always the country that people associate it with, and therefore the general perception of the population is that you need to live next to a volcano. I'll talk a little bit later about why this isn't the case. Something I refer to as seismic hooliganism is the creation of earthquakes by a certain type of geothermal solution, and that's the engineered geothermal system. Now, these systems usually are associated with drilling into basement rocks and either fracturing formations in granites or metamorphic rocks and then pumping water through them. Sometimes it's just a case of using existing fissures and faults, but injecting water into these reservoirs or environments that don't normally have fluid is something that can be catastrophic regarding the projects are concerned. If you inject cold water onto hot rocks which have high temperatures, then quite often the shock of the temperature and pressure change can result in activation of existing faults, and this in turn will cause earthquakes. The best example of this is something that happened in, I guess, 2018-19 in northern France, a place called Vendenheim near Strasbourg. The project had finished, all wells were drilled, injection began, and a 2.9 earthquake was generated. A 2.9 earthquake is enough to significantly be felt at surface, particularly in locations that don't normally see earthquakes. As a result, the project was shut down. Actually, the earthquakes continued for at least 18 months afterwards and increased in magnitude during that time. Geothermal is also associated with expense and being time consuming, and that's not necessarily something that investors are looking for. And the final black mark against geothermal energy is the risk due to subsurface uncertainty, and this is related to the reservoir modelling not being that accurate, drilling wells which are anticipated to connect in the subsurface, but they don't. So in essence, the project is drilled. You have 2 or more wells. The injection water is presented to the first well, and it then gets to the subsurface at the TD of these wells and disappears, never to be seen again. Obviously, that's a failed project, and this is something that has counted against the geothermal industry. All of these basic failure mechanisms have led to a relatively bad reputation in the investment forum. So now looking at the reasons that geothermal is changing, and I'll start with those perceptions of the past and how we are solving them. First of all, the concept that we need to live next to a volcano. Now, on the right-hand side of this slide, you can see a geothermal map of temperatures at 1 kilometre in Great Britain. The dark orange represents 58 degrees Celsius at 1 kilometre, and the dark blue represents 18 degrees per kilometre. Now, there are a few places on this map that can potentially generate electricity. That direct heat turned into electricity is not always the best solution. And I'll talk about this a little bit later on. But in essence, anywhere on this map of Great Britain, we can generate heat from a well. Now, this heat could be used for a number of things, ranging from heat for agricultural purposes, direct industry or district heating and cooling processes. So it's important always to look outside the box and think about what your local population is using heating and cooling for, to see if it can be replaced by geothermal energy. Seismic hooliganism, as I call it, can also be mitigated. And this, to a degree, is due to new technologies being introduced by the oil and gas business. It's also related to different forms of geothermal systems which can be embraced. As far as the time-consuming and expensive part of the business is concerned, mitigation here comes from oil and gas. Over the last 5 to 10 years, the geothermal business has begun to embrace oil and gas technologies, and also look at how those technologies can be used to optimize the drilling of wells. The green text I put here is particularly a well conversion, and this is related to repurposing oil and gas wells into geothermal producers. That's again something I will talk about a little bit later. But clearly, if you don't have to drill the well, then the whole project becomes less expensive. The subsurface risk and uncertainty. Hello?
I'm sorry to disturb, sir, but can you please tell which slide are you presenting right now?
I'm currently on slide 4, and you should see a map of the UK.
Sir, we are still seeing slide 1, so there's something miscommunication. Yes, sir. Now we are seeing slide 4. Yes.
Okay. I'm going to have to scroll through these one by one using the tab on the side. Okay, tell me, can you now see the next slide?
Yes, sir. 5th slide we are seeing.
Perfect. Thank you very much. Sorry about the confusion, guys. Okay, this slide is rather dull, but it's also perhaps the most important. And this talks about the benefits of geothermal energy, specifically compared to other renewables and also mainstream energy uses like oil and gas. So the most important thing when looking at geothermal is that it's baseload. And this means, in essence, that we produce energy 24 hours a day, 7 days a week for 364 days a year. We need to shut down 1 day a year for maintenance purposes. And this ability to have a renewable energy, which is 24/7, is something that sets geothermal apart from wind and solar, which of course are the main renewables that are considered when everyone talks about sustainable energy. The fact that geothermal is off-grid is also incredibly important. This means that we can use geothermal in remote locations, for example, island or even desert environments, where you have populations which don't benefit from infrastructure due to either the size of the countries or the development of the individual location. So we can go to a remote population that actually has reasonable geothermal conditions and provide them with electricity, say, whereas before they would perhaps have been dependent on diesel generation, which can be very expensive depending on where you live. The cheat note I have here says remember Texas, and the reason for that is that 3 years ago in February, there was a severe snowstorm in Texas, which led to catastrophic infrastructure failure. And that infrastructure failure in turn led to the loss of life. More than 100 people died in the US because of this loss of power. So the fact that geothermal can provide an off-grid solution is also very important. Energy security is something that is becoming more and more publicized, I suppose, particularly in places like Europe, where we've had very, very high gas prices over the last few years. Gas is one of the main sources of our electricity for the grid, but in Europe, particularly the UK, our electricity prices today are higher than they've ever been before. And this is because of the fluctuating prices in the gas market. And because of this, then some industries, some particular businesses have had to shut down because they can no longer afford to pay for the energy for their particular industry. So the fact that once a geothermal plant is up and running, you have a guaranteed fee for your energy, whether that is heating, cooling, or electricity, for many, many decades, helps industries, it helps regional governments or small settlements, because it means that they can predict their financial outlay for that time. Geothermal energy also provides or can provide food security by providing heating for glasshouse complexes, for example, or heating for agriculture. In Iceland, the best example, there is a 11,000 square meter glasshouse complex, which provides 40% of the country's tomatoes. Growing tomatoes in Iceland is not something that would have been considered before geothermal energy. We can also provide electricity for green hydrogen or EV charging, which gives geothermal energy a transport element. And finally, there is the benefit of employment, which comes with projects. Has the slide switched to the next?
Yes, sir. Currently, sixth slide.
Perfect, thank you.
Yes.
Right, so let's look at energy use now, and this is a very important factor regarding global energy use. Actually, starting with the UK, over 50% of household energy is used for heating spaces or water. Now, this is incredibly inefficient, I beg your pardon, because essentially what we're doing is we're transporting gas from a hub or electricity from a hub, which is then being used as being converted into heat for spaces and water. In the Middle East, they do the same thing, about the other way around. More than 70% of their energy is used for cooling. And it's the same with an industry. If you look at industries, they use electricity or gas for things like drying, cooking, washing, sterilizing, distilling, brewing, pasteurizing, etc., and cooling, of course. Geothermal energy can decarbonize these processes by providing direct heat. Which brings us on to the energy uses for geothermal energy. The bottom half of this slide, the red circles are related to direct heat uses, and the yellow is related to electricity. At primeval energy, when we are approached by potential partners, we always look for a heating or cooling purpose for the energy in order to replace electricity. And the reason for that is that it's a far more energy efficient process. So as I've already mentioned, Heating could be used for agriculture, aquaponics. It can be used for drying things like tea and coffee, or any other crops that require drying. As a result, for example, it might be good for bulk storage of any goods that need to be kept dry. So, for example, it would be a good solution for ports globally. The commercial greenhouses are a great recipient of heat, as are paper mills, district heating and cooling solutions, whether that is in relatively small communities or actually citywide. It's possible just about everywhere. Referring back to the map of the UK, we can provide direct heat anywhere on that map. And the UK has very modest geothermal temperatures. Our gradient is actually the global average. It's about 30 degrees Celsius per kilometre on average. Heat can also be used for desalination and water treatment, something that is required just about everywhere. And even if you have modest temperatures, then heat from geothermal can be used for these processes. Additionally, I've already mentioned breweries and dairies, any processing industry which requires heat. It's a great alternative solution, and as I've already mentioned, it is far more efficient as far as energy use is concerned. Converting one form of energy to another is a poor use of energy generally. As far as the electricity use is concerned, of course, there's direct supply to industry and domestic users. There are also more remote solutions, for example, EV charging in the middle of nowhere. There are quite often infrastructure problems with EV charging in large countries. Green hydrogen and ammonia creation is a way of, again, having remote use of geothermal energy. If you have a location in the middle of nowhere, which is ideal for the production of geothermal electricity, but you don't have a local population to feed that electricity to, then you can basically use the electricity to generate hydrogen, and that can be stored in the form of ammonia and transported to wherever it might be used. Likewise, with data centers, where we require electricity in vast amounts, but not necessarily a large population. It is possible to use that geothermal and have a viable project. So just having a very basic look at the solutions available. Most people will perhaps be familiar with ground source heat pumps. It's a useful way of utilizing geothermal heat. In this instance, relatively shallow wells are drilled down to, let's say, a maximum of 500 meters, and the energy is transported to the surface in the form of heating. It can be reversed to do cooling as well, and it produces heating or cooling to buildings. Now, this is something that can be used to a certain scale for domestic use or industrial use with glass houses, and is used to great effect. But the downside of ground source heat pumps is the fact that they are scalable only to a certain degree. This is when we jump over to what's referred to as deep geothermal solutions. If you look to the middle of the slide, you'll see the open loop solution, which is the traditional solution, and this solution is something which has been used for more than 100 years, whereby 2 wells are drilled and the water is injected to the first well and travels through the subsurface, harvested by the second well, and pumped to the surface, and hopefully that well produces heat which is sufficient for the end's use. What is relatively new as far as its development is concerned is the closed loop solution, and this is one of the the main focuses of new companies which have come in from the oil and gas business. Closed loop solutions are essentially a single well, usually, which is cased off from the subsurface completely. So you drill a well to whichever size is required, case it, and then cement it, which means you have complete isolation from the geology at depth. This means that you do not have any benefit really of fluid flow through your well from the outside formation. However, the upside of this is that you can produce geothermal solutions just about anywhere. Going back to the map of the UK, if you require modest temperatures, a closed loop solution might be what you need. The downside of closed loop solutions is that they rely on conduction for heat transfer. And this is something which is less efficient than the convection which open loop solutions use. As a result, it's always better, if possible, to look for open loop solutions before you look for closed loop solutions. So I'll touch on some of the new companies which have sprung up over the last 5 to 10 years. All of these come from an oil and gas background to varying degrees. They all use oil and gas technology, and without oil and gas technology, none of them would exist. The first one I'll talk about is SPE Energy, and this is the most basic form of the new geothermal, and it is a vertical closed loop well. Now, this is simply a well which is drilled to whichever depth is required to achieve the temperatures that are needed. Cased off, a secondary tubing is put in the middle of the well. Hot water is pumped down the annulus of this well. It comes up the secondary tubing in the inside of the well and is used to provide heat to the local community in the form of whatever that might be required, district heating, agriculture, industry, etc. As I've mentioned, this is the most basic solution. It's a good solution where you just require heating and cooling, but again, not as efficient as open loop solutions. Greenfire Energy is a US-based company. They have a variation of the closed loop well in that they perforate the outer side of the well, the casing, and they insert a completion which is self-contained. And in this completion, you pump the fluid around. The fluid could be anything you like because it is still segregated from formation water, but it does benefit from having fluid circulating closely around the closed loop solution. It's still not as efficient as open loop, but it's a good solution in the right situation. I'll move on now to a couple of the most significant geothermal companies that have arisen in the last 10 years. Evor is perhaps the most famous closed loop solution. What they do is they plan and drill 2 wells, which are then connected deep in the subsurface using oil and gas technology. Again, they use magnetic ranging in order to join these 2 wells. And the wells, basically, because they communicate in the subsurface, and they're still sealed off from subsurface fluids, which makes them a closed loop, but they have a significant amount of pipe underground. As a result, it means they benefit from a greater, what we call residence time. The fluid is exposed to the high temperatures for longer. So even though they're using conduction to transfer the heat, because they have such a long length of pipe underground, then it means that more heat is transferred into the system. The image on the left is the first iteration of Evor's solution, something they call the Evor loop. And the reason that it disappeared is the fact that this particular solution is technically very challenging. Having what they wanted to have was 100 kilometers of well looping around in the subsurface and connecting. That's very difficult, as most of you will know, which is why everyone changed their design and moved on to the design on the right, which is a pitchfork approach, whereby you have a single well with multiple sidetracks, which are connected to a second well with multiple sidetracks, which are shown in them, and connect at the bottom, and therefore you have essentially two wells connected in the subsurface with a great deal of exposed pipe to increase the heat exposure of the system. Again, it's closed loop, but it's a good solution. The problem I see with Evor's approach is the fact that it's going to be very expensive. There are a couple of wells, in fact, a few wells being drilled in southern Germany at the moment. They have two rigs in the Munich Basin, and this project will be expanded next year into 4 wells and will be completed in, let's say, 3 to 4 years. The final company, which comes from oil and gas, has used a combination of directional drilling and also nuanced completion solutions in order to create further exposure and greater exposure indeed than previous geothermal wells. This is an open loop solution and it has become very successful. So Fervo started by drilling 2 wells in Nevada. They drilled these wells in an area of metasediments which had a proven geothermal ability. But what they did is they drilled wells which were, let's say, 2.5 to 3 kilometers deep, and then with an offset of 2.5 to 3 kilometers. The wells were parallel at depth. They were then fracked. The communication through these metasediments was a success. And essentially what they did is they pumped water down one well, it transferred to the second well, and was produced at high enough temperatures and flow rates to generate 3.5 megawatts of electricity. At the time, which is about 2 years ago, it's the most successful geothermal operation ever. It's important to note here that this is all oil and gas technology that helped with this process. And since the commercial of this new approach, the data center aspect has been embraced by Google. They have a new project in Utah and drilling dozens and dozens of wells in order to ultimately generate 2 gigawatts of electricity. So moving on, the last thing I'd like to talk about as far as the new technological approaches are concerned is something that we refer to at Primeval as geothermal alchemy. And this is where we take existing oil and gas wells and convert them to geothermal producers. Now, this has been done in a few cases around the world, but always embracing heat or cooling. This has never been done to produce electricity, and this is kind of important. What we're doing at Primeval is we're looking at, rather than using individual wells, we are using clusters of existing oil and gas wells, and essentially the wells which are designed in these clusters to inject water and produce oil when they become close to the end of their useful life and are ready for suspension or abandonment, we can jump in, use a great deal of that existing infrastructure, and using a mix of oil and gas reservoir engineering and geothermal modeling, we can predict the temperatures which could be sustainably maintained by circulating fluids through those clusters of wells at constant flow rates, providing constant temperatures at surface. In the worst case scenario, these wells will provide considerably more heat than converting in a closed loop. In the best case scenario, and it doesn't take very much, it's possible to generate enough constant heat at surface to be able to plug in a binary system, organic Rankine cycle, and produce electricity from existing oil and gas wells. Now, this sounds challenging, but for those with a knowledge of wells, you'll understand that the process is relatively straightforward. We need wells with a specific condition. They need to be of a certain architecture, but we think that around about 10 to 20% of wells globally, which are nearing the end of their life, can be used for well conversion. And this is kind of important. If you, in places like Texas, for example, indeed onshore India, you look at how many wells that you have. Texas has 1.4 million wells by itself. Think about the potential of converting 10 to 15% of those into geothermal energy producers. It's a vast potential industry, and it will grow with time. So looking at all these new approaches and the old approaches, we ask ourselves which approach is the best. Is it closed loop? Is it open loop? Is it the nuanced closed loop? Or is it the conversion? And the simple answer is it's all of the above. It's important when looking at optimizing any solution to be given a choice of every technology available. And this is something which led to the creation of primeval energy. What we do is we provide a technology agnostic geothermal approach. And this goes all the way from cradle to grave. We look at pre-feasibility studies, feasibility work, front-end engineering design, project development, drilling of wells, commissioning of geothermal facilities. And because we have a couple of finance people on our board, we can actually also provide project finance and be a partner within these developments, and therefore a long-term energy producer. The image here is effectively our what we call our geothermal toolbox. It is a depiction, first of all, on the left-hand side of oil and gas well conversion. We can look at an entire field and do a study which will pinpoint the wells which are suitable for closed loop, those clusters which are suitable for open loop, and it will also look at the wells which can't be converted. And on the right-hand side of the panel here, you'll see that we also offer well abandonment and decommissioning. This is important because it's a full environmental approach for end-of-life wells. We also offer for the right location closed-loop solutions where minimal amounts of heating or cooling are required. We will offer open-loop solutions also. This is in fresh wells. In most of our designs and open-loop scenarios, we will design in a closed-loop fallback so that we have risk mitigation within that project. Something else that we're looking for or into at the moment is we're providing, we're raising funds for research and development into compressed air energy storage. The reason I like compressed air energy storage in wells is the fact that we can essentially drill wells next to solar or wind farms. Those wells can be absolutely isolated from the formation, so geology is not important. The wells are cased. We then store compressed air via compressors run from the wind and solar, and the energy can be stored up to, let's say, 15 hours, then released to a turbine, which generates electricity. This is a solution which does benefit from heat at depth, actually. So it has a geothermal element. Heat at depth creates more pressure, and as a result, it means that you have a greater resource in the well. One of the benefits of compressed air energy storage is the fact that we can replace batteries, and batteries, even though they have their place today, they suffer from a great many setbacks, including the fact that they need to be replaced every just over 8 years on average. And they also have that environmental association, of course, that I mentioned earlier on, because of the fact that they use rare earths. So looking at the geothermal industry as is today, last year the business was worth about $7 billion. This is tiny. If you compare us to oil and gas, which is worth more approaching to $7 trillion, the difference is huge. However, I have to emphasize, and this is the second time I've mentioned it in this presentation, that the International Energy Agency predicts that geothermal will contribute 15% of global electricity by 2050. Now, this is a huge statement. The International Energy Agency has a very strong reputation, and for them to come out with this statement is incredibly encouraging for the geothermal business, and their conclusions are based on the development of geothermal over the last 5 to 10 years, and this is related to oil and gas solutions, personnel, and finance. So what's driving this expansion of the business? It's a number of things. First of all, there's government regulation, which is leading to greenhouse gas emission reduction, and this is aspirational for many governments, both regionally and nationally. It's something which is becoming more important for many and less important for some, but it's not going away generally. Also, individual companies are looking to become greener, and as a result, they're looking for the most efficient energy solutions they can find. As a result, the geothermal business has benefited. I already mentioned the technology approaches. Oil and gas being inserted into geothermal is a massive reason for the expansion of the business, as well as, of course, the investment from oil and gas companies. For example, both Chevron and BP have invested in Evor, and numerous other companies. Devon Energy, for example, holds a very large share of Fervo Energy. So this combination of factors has led to a significant increase in the geothermal market, and will continue to do so over the next 25 years and onwards. So because I have an oil and gas audience, I think it's worth touching on transferable skills of people from oil and gas. Essentially, if you work in oil and gas, or you have an aspiration to work in oil and gas, all of your skills are transferable to geothermal. And that ranges from geoscientists, because we need all of those in our modeling and in our well design, etc. Engineers for well design, execution, intervention, etc. Everybody who has worked in oil and gas for a long period of time will have project management skills. And of course, these are invaluable in every industry, but of course, you have project management skills which hail from oil and gas, then those are easily transferable to geothermal energy. Likewise, if you have experience using in the mid and downstream of oil and gas, for example, production facilities, it's relatively simple to step across into geothermal energy because you have that technical approach which can be used in geothermal energy. That's kind of some of the more technical stuff, but we also need people who work in commercial, in contracts, in process optimization, in legal. We need electricians, we need plumbers, we need absolutely everybody. So you can see that if you work in oil and gas, there will be a place for you in geothermal. But it's worth pointing out or focusing that the geothermal business is much, much smaller than oil and gas. So there are a great many people from oil and gas who are trying to step across from that industry to geothermal. And as a result, it's not something that's easily done. This is a picture of me apparently having a laugh with Primeval Energy's Chief Subsurface Officer, Tanya. And the reason I put this image up is because Tanya and I come from quite different backgrounds. Mine is very humble. I only have 1 degree. Many people now have 2, 3, or even 4. I jumped into the oil and gas business as a mudlogger, and then I worked on rigs as a well site geologist, so 11 years on rigs in total. I then moved on to operations geology, which is a very technical aspect of geology stroke engineering, and then became an operations geology team leader and manager. And then I switched over to operational optimization, process optimization, and cost reduction. That was kind of the end of my oil and gas career. I then switched over and became a subsurface manager in geothermal energy, and then I moved on to my current role. If you look at Tanya, she comes from a more academic background. She has 3 degrees in geoscience, first of all, then petroleum geology, and then in renewable energy. She is a seasoned geomodeler. She is a specialist in reservoir characterization and reserves management. She has been working in renewable energy for as long as I have, 5 years. And Tanya has done that through initially looking at carbon footprints modeling. She went on to become interested in geothermal energy, and she's become a specialist in well conversion of oil and gas to geothermal. And today, as I mentioned, she's the Chief Subsurface Officer at Primeval. Now, we both started off as geoscience bachelors, graduates, but we've taken very different paths. But these 2 roles that I'm showing you could equally be a geologist and an engineer, or a geologist and a lawyer, or a commercial person. But what I'm trying to emphasize is the fact that no matter where you come from, there is a place for you in geothermal energy. So going through then now the actual skill sets that we have applied and apply today. Both of us do project management and optimization of processes and operations. Both of us work in business development and client liaison. I work in geothermal studies QC. Tony works in the supervision of those studies. I work in relationship building, strategy, as does Tanya. But essentially, the fact is that when you get to a certain stage in your career, you can pivot to various different stages in the geothermal energy system. And that's something that I would like to impress upon the audience, that in essence, no matter what your role in oil and gas, there will be a place for you eventually in geothermal if that's what you choose to embrace. So that's the end of the presentation. I'm sorry I couldn't put it in presentation mode, but there we are. Before I stop talking, I'd like to highlight the fact that one of the biggest obstacles we come across in geothermal energy is the awareness of the public and of governments and industry about the potentials of geothermal. So I would invite you all to talk to anybody you can about geothermal. It's a great solution. If you'd like to hear more, please email me at the address on the screen, or feel free to connect with me on LinkedIn. I would also encourage people who are interested in geothermal energy to follow Think Geoenergy on LinkedIn, because it is an excellent way of keeping up with the news. Thank you very much for your time. I'll now open the floor to questions.
Thank you, Mr. Wood. It was quite a wonderful presentation. Thank you for sharing your valuable insights. We have received several great questions from our participants. Let's dive into them.
The first question is, many people associate geothermal energy with volcanic regions. How feasible is it to expand geothermal energy to non-traditional locations, and what new techniques and innovations can make this possible?
Great question. Think of India. Think of how many geothermal plants you have in India, and then think about your tectonic setting. India benefits from amongst the best geothermal gradients globally, yet it does not have a huge geothermal industry. There is massive scope for India. Just using you because I'm talking to an Indian audience. Let's look at, for example, the four solutions, the four technological solutions that I mentioned from the new companies. If you have a dairy in your local area which is producing milk, cheese, etc., they will need heat. I can drill a well in the car park of that dairy and replace their current heat provision with geothermal energy. I could do that anywhere in the world, absolutely anywhere. Think about how many dairies there are. Think about how many distilleries there are that create spirits, or breweries. Think about all of those direct heat users. So that's the most basic form of geothermal. Then we go on to the most oil and gas embracing solution that further offers, that primeval energy can also offer, and that's the twin directional wells, which basically use oil and gas directional drilling, use oil and gas completion solutions. In India, there will be hundreds of locations where that can be done, but it's not being done. This is not rocket science. This is oil and gas science, and we all know how we can apply those things. Just think about what you guys in this audience know about geothermal energy. Take a look at a geothermal energy map of India, which you can do, by the way, using Project Inner Spaces GeoMap. It's a free tool which is available online. It takes about 5 minutes to get used to, but it will tell you about the geothermal gradients in your local area. Now, just talking about India, with its advantageous geothermal gradients, just about anywhere in your country, in 10 years' time, will have geothermal energy, either direct heating and cooling or electricity. There will be more electricity generation in India than other places because of the gradients that we benefit from. But in essence, the answer to your question is absolutely everywhere. Of course, you also have an existing oil and gas business in India, and there will be oil and gas well conversion to geothermal producers. In fact, Primeval Energy is already looking at that in India. I can't tell you with who, but it's something that will come with time. I hope that answers the question.
Yes, so thank you. That clears the questions that out. And the next question we are having from Mayuk, it is unlike solar and wind, which receive significant investments, geothermal often struggles to gain the same level of funding and policy backing. What key policy changes or business models do you think could accelerate the global geothermal adoption?
Another good question. The reason that wind and solar have proliferated is twofold, really. First of all, it's awareness. When you talk about renewable energy, everybody says wind and solar. Almost nobody says geothermal. So the awareness aspect is important. Those two industries also benefit hugely from government awareness, and that government awareness comes from lobbying. It also comes from the existing projects which are known about by government ministers in various places. So if you go to the Caribbean, for example, most people will know about geothermal energy, particularly in the Eastern Caribbean. They don't have many successful projects at the moment, but they are looking into it. Their governments are looking at the potential of policy for licensing of geothermal facilities that will in turn lead to proliferation. Where I'm from, the UK, we have absolutely terrible policy when it comes to geothermal energy. As a result, proliferation of geothermal in the UK will be much, much slower than most parts of the world. Go across the English Channel to Germany, and they are embracing geothermal. They have existing geothermal plants in the Munich Basin, which are producing direct heating and electricity through limestone reservoirs. And because of that and new technologies, the government of Germany is helping to bring in more geothermal investment and even investing themselves in geothermal. So it's very much down to perception, awareness, policy and support from governments. I can't highlight enough the support from governments aspect. There are some governments in Central and South America, for example, who don't have geothermal energy but are already developing geothermal energy policies for licensing and helping geothermal proliferation. That is forward thinking. I know that there are elements within India which are looking at not necessarily lobbying, but promoting awareness of geothermal. But the real key is to have a successful geothermal well on the doorstep of politicians. And I think that until that happens, because politicians are interesting people, they don't like to take risks, and they don't like to put their name to things that might fail. If you have a geothermal solution that is sitting on a politician's doorstep, which is successful, then he's going to talk about it. So another key to more geothermal energy is more geothermal energy. At Primeval, for example, we look to proliferate geothermal energy. We look for our projects without government support. But the fact that we will start producing geothermal in locations that don't currently have geothermal will mean that people pay attention. When people pay attention, investment will follow. So it's all about really awareness and policy.
Thank you, sir. We have another question. With the rise of enhanced geothermal systems, there's a hope for scaling up energy source. What are the biggest technical challenges still facing EGS, and how close are we to making it commercially viable?
That's a really good question. EGS is perhaps the least predictable of the geothermal solutions. The reason for that is that you accurately need to to be able to model the subsurface, and that's related to faulting, fracturing. Now, for the geophysicists and geologists amongst us, you'll know that you can't really model fractures at depth. They are subseismic. So there is always going to be a gamble. However, I should add that because of the very advanced modeling software that we have in oil and gas, the EGS projects are already becoming better and more successful. The number I quoted 5 years ago for their success was 75%. That number is now closer to 80 or 85%. If you're clever about the approach, as Fervo are, then their success is 100%. But this is because they have chosen the right locations. They've chosen metasediments. You can also do these in regular sediments if you have high enough temperatures. But it's something that is about choosing the right location and making sure that that location is somewhere with a predictable subsurface. For example, if you've drilled 100 oil and gas wells, all that have cores and that show you that a formation is fractured at depth with good temperatures, then you know that that would be a good location to drill geothermal wells. So it's a case of using existing technology, using data that we already have, and being sensible about the approach. There are companies, organizations, which are drilling absolute wildcat wells in the middle of nowhere where there's never been a well drilled before, but those are the risky wells. So it's the same approach as we look at when we're drilling oil and gas wells. If you're drilling a formation or a region of known resources, then you're more likely to be successful. Whereas we all also know that 25% or 20% even of oil and gas exploration wells are successful. So exploration is a risk, whichever business you're in, but the exploration aspect is coming more and more. So in essence, it's about offset data, choosing the right formations, and using oil and gas technology to allow those EGS systems to succeed.
Thank you so much, sir. The next question we are having is from Lupal. It is transitioning to net zero requires not just technology but also community and public engagement. How can local communities and individuals play a role in advocating for and benefiting from geothermal energy projects?
Yeah, this comes back to the awareness aspect. For example, I know a few people who are geothermal evangelists, and they talk to their local communities about offering geothermal solutions to their local area. As I've already mentioned, awareness is the biggest side of getting those projects advocated. It's going to come from advocacy. So people with the knowledge, people who are spreading the awareness will lead to that community engagement. Community engagement is a very strong tool. The grassroots aspect of geothermal is also growing. For example, I'm talking to somebody in North Dakota in the US who is a very, very keen geoscientist and wants to use his knowledge in order to bring geothermal to certain places within North Dakota. As a result, he's talking to me. He's talking to his local community. And it's that same thing. If you want it to happen in your backyard, then make it happen. Talk to the people who can help. Talk to your neighbors, get them to talk to the local government. It's about proliferation of knowledge, sharing that awareness, and contacting the people who can help.
Thank you, sir. So now as we conclude today's session, I want to express my heartfelt gratitude to Mr. Andy Wood for sharing his expertise and vision with us. Your insights into geothermal energy's role in the net zero transition have been both enlightening and inspiring.
And we are also sorry for the disturbances, all that whatever happened, sir. But before we wrap up, Mr. Wood, do you have any final thoughts or key takeaways you would like to leave us with?
Absolutely. I always do. I spoke about geothermal evangelism earlier on. It's a label that I brand myself with. Um, One of the many reasons that I give presentations to the SPE and other organizations is that I am doing my best to spread awareness. More than 50 people have dialed in today. Thank you very much for your time. Please go out and tell your neighbors, tell your friends, tell your colleagues about geothermal energy. And if you'd like to talk to me about projects, then please feel free to reach out. I'd also like to thank the SPE for inviting me and helping me to spread the word.
Thank you once again, sir, for your time and invaluable contributions. We look forward to seeing how geothermal energy continues to reshape the renewable energy landscape.
Thank you very much.
And to all our attendees, thank you for joining us. We hope this session has provided you with new knowledge and an inspiration to explore the geothermal energy's potential. We officially conclude today's webinar. Have a great evening.